The role of oracles in smart contracts and decentralized finance. Oracles play a pivotal role in the functionality and expansion of smart contracts and decentralized finance (DeFi) ecosystems. Smart contracts, which are self-executing agreements with the terms directly written into code, operate on blockchain networks and are designed to automate processes without the need for intermediaries. However, smart contracts are inherently limited by their inability to access external data, as blockchains are closed systems. This is where oracles come in. They act as bridges between blockchain-based smart contracts and external data sources, enabling smart contracts to interact with real-world information. In the context of DeFi, oracles are indispensable for enabling complex financial applications, such as lending, borrowing, trading, and insurance, by providing accurate and timely data. Without oracles, the potential of smart contracts in DeFi would be severely constrained, as they would be unable to respond to real-world events or access critical information needed for decision-making. The primary function of oracles is to fetch, verify, and deliver external data to smart contracts. This data can include a wide range of information, such as market prices, weather conditions, sports scores, election results, or even IoT sensor readings. For example, in a DeFi lending platform, a smart contract may need to determine the value of collateralized assets in real time to ensure that loans remain adequately backed. An oracle can provide the necessary price feeds from external exchanges, enabling the smart contract to execute actions like liquidating collateral if its value falls below a certain threshold. Similarly, in decentralized insurance protocols, oracles can provide data on real-world events, such as flight delays or natural disasters, to trigger payouts automatically. By enabling smart contracts to interact with external data, oracles expand their utility and make them applicable to a broader range of use cases. Oracles are particularly critical in DeFi, where the accuracy and reliability of data are paramount. DeFi applications rely heavily on price feeds to function effectively, as they underpin activities such as trading, margin lending, and derivatives. For instance, decentralized exchanges, DEXs, use oracles to determine the prices of assets for trading pairs, while synthetic asset platforms use them to peg the value of digital tokens to real-world assets like gold or fiat currencies. Inaccurate or manipulated data can lead to significant financial losses, as seen in several high-profile DeFi exploits, where attackers exploited vulnerabilities in oracle systems to manipulate prices and drain funds. Therefore, the design and implementation of oracles are crucial to the security and stability of DeFi ecosystems. There are several types of oracles, each serving different purposes and use cases. The most common types include input oracles. These oracles fetch data from external sources and deliver it to smart contracts. For example, a price feed oracle that provides real-time cryptocurrency prices to a DeFi platform. Output oracles. These oracles enable smart contracts to send data or commands to external systems. For instance, a smart contract could use an output oracle to trigger a payment on a traditional banking network. Cross-chain oracles. These oracles facilitate communication between different blockchain networks, enabling interoperability. For example, a cross-chain oracle could allow a smart contract on Ethereum to access data from a blockchain like Binance Smart Chain. Compute-enabled oracles. These oracles not only provide data but also perform off-chain computations. This is useful for complex calculations that are too expensive or impractical to execute on-chain. Decentralized oracles. These oracles aggregate data from multiple sources to reduce the risk of manipulation or single points of failure. Decentralized oracle networks, such as Chainlink, use multiple nodes to fetch and verify data, ensuring greater reliability and security. Decentralized oracles are particularly important in DeFi, as they address the trust issues associated with centralized oracles. Centralized oracles rely on a single data source or provider, making them vulnerable to manipulation, downtime, or censorship. In contrast, decentralized oracle networks distribute the responsibility of data fetching and verification across multiple nodes, reducing the risk of malicious actors compromising the system. For example, Chainlink, one of the most widely used decentralized oracle networks, employs a network of independent node operators that retrieve data from various sources and use cryptographic proofs to ensure its accuracy. This decentralized approach enhances the security and resilience of DeFi applications, making them more robust against attacks and failures. The integration of oracles into smart contracts and DeFi platforms has unlocked a wide range of innovative use cases. One notable example is the emergence of decentralized prediction markets, where users can bet on the outcome of real-world events, such as elections or sports matches. Oracles provide the necessary data to resolve these bets accurately and transparently. Another example is parametric insurance, where payouts are automatically triggered based on predefined conditions, such as a hurricane reaching a specific wind speed. Oracles supply the data needed to verify these conditions, enabling seamless and trustless claims processing. Additionally, oracles are enabling the tokenization of real-world assets, such as real estate, art, and commodities, by providing the data required to peg digital tokens to their physical counterparts. Despite their critical role, oracles are not without challenges. One of the main issues is the oracle problem, which refers to the difficulty of ensuring that the data provided by oracles is accurate, timely, and tamper-proof. Since oracles act as intermediaries between on-chain and off-chain systems, they introduce a potential point of failure. If an oracle provides incorrect or manipulated data, it can lead to erroneous outcomes in smart contracts, resulting in financial losses or other unintended consequences. To mitigate this risk, developers are exploring various solutions, such as using multiple oracles to cross-verify data, implementing reputation systems for oracle providers, and leveraging cryptographic techniques to ensure data integrity. Another challenge is the scalability and cost of using oracles. Fetching and verifying external data can be computationally expensive, especially for decentralized oracle networks that rely on consensus mechanisms. This can lead to higher transaction fees and slower processing times, which may hinder the adoption of oracle-dependent applications. To address this, some projects are exploring Layer 2 solutions and off-chain computation to reduce the burden on the main blockchain. In conclusion, oracles are indispensable components of smart contracts and decentralized finance, enabling these technologies to interact with real-world data and unlock their full potential. By providing accurate, reliable, and tamper-proof data, oracles empower DeFi applications to offer innovative financial services, such as lending, trading, insurance, and asset tokenization. However, the design and implementation of oracles must address challenges related to security, scalability, and cost to ensure their long-term viability. As the DeFi ecosystem continues to evolve, oracles will play an increasingly important role in bridging the gap between blockchain-based systems and the real world, driving the next wave of innovation in finance and beyond. Oracles are the backbone of smart contracts and decentralized finance, DeFi, bridging the gap between blockchain and real-world data. As DeFi continues to grow, understanding the role of oracles is crucial for anyone interested in blockchain technology and financial innovation. What do you think about the future of oracles in DeFi? Will they enhance security or introduce new risks? Share your thoughts in the comments. Like, subscribe, and hit the notification bell to stay updated on the latest trends in blockchain, smart contracts, and decentralized finance.